Well, I mean, I can barely take one.
Honestly.
I've taken 2, and it was a little rough. I know people who've taken more than 2, and they are fine. Yeah. So I can't do that. So I'm like barely reaching 64. And then while others, they easily get to 80, 90. Sure.
One of my friends was like, I finished the major freshman year.
Wait, is that even possible?
I think not the whole major, but like the core requirements maybe.
Wait, except for the senior thesis, he was like, as far as math is concerned.
So he got like 60 units.
I think he was like I think he had units coming in, like from the local community college.
Did he take 15 units? 15 units of math?
I think he was in like 4 or 5 classes.
Wow.
So the previous 106L lecturer, he was a math major too. He set the record of 6 math classes. Yeah. He told me he ended up getting 2 incompletes, but you know, he's 6 math classes. She said that was one of the worst decisions he's ever made.
I just don't understand why you.
I'm glad this is
Like
permanently on.
Like 6 p-sets a week. You did 6 p-sets a week.
Really do 2.
I can barely do 1. So yeah. Yeah, like, so you don't have to, like, what I've learned is you don't have to be the best. You're not going to be the best at everything, and that's fine.
Where's wisdom?
I am clearly an upperclassman.
Wait, so you were here like next year and year after, right?
So I'll tell you later.
All right. Welcome, everyone. Thank you for coming during midterm week as well. So you guys, I guess, get the special experience since you get to be here and participate, because we're going to basically today just be doing one large example that uses everything that we've learned about the STL, which will also be helpful for assignment 2. All right. Okay. So before we do that, though, just to give a little bit of wrap up on the STL. So to give you guys a sense of how far you've come, if you remember, this was the thing that we first saw when we were looking at the STL something like 5 lectures ago, and now you guys understand what every part of this means. For example, containers, we've looked at vectors, decks, lists, sets, maps. We've seen container adapters. Can anyone shout out what are container adapters examples? What are examples of container adapters?
Like stacks.
Yeah, say it louder. Stacks and queues, container adapters. Turns out they're actually not containers themselves. We've seen iterators, in the 4 functions on iterators, like .begin, .end, dereferencing, and incrementing iterators, along with the 5 types, input, output, forward, bidirectional, random access. Honestly, when it comes to like the types of iterators, we went over those pretty quickly. So if you're still confused on what are the differences, I'd encourage you to go back and look at the slides. But really, the key thing to take away is that each one promises a different level of the amount of capabilities that it has. And so if you're ever looking at a data structure and you see that it says something like forward it, now you know, okay, I need to go back and look at what a forward iterator promises so that I know how to use this data structure. You guys have seen iterator adapters with Avery. Does anyone remember an example of an iterator adapter? Raise your hand. Yeah, this one's a little tricky.
So you use a back insertion?
Yes, absolutely. Yeah. So Avery covered. There was this idea that you can use something like a back inserter. So say you wanted to copy over elements, you're not guaranteed that there's enough room in the thing that you're trying to copy to already. So use a back inserter, which is this layer that the STL has wrapped around the iterators you already know, so that it can increase the memory as you're doing so. So yeah, exactly. So things like back inserters. If you remember, we were able to write to C out without actually using C out, alligator, and then the value, by using copy as well. So copying directly to the O stream iterator. So that's another example of an iterator adapter. So again, sort of like tying all of these concepts back together. You guys have seen functors and lambdas now. And in fact, there are also things such as or function adapters, which we didn't actually talk about. Part of that is because they're actually going out of use in C++ 20. So function adapters have really been replaced by lambdas now. So you guys know lambdas, that's all you need to know. And then finally, of course, our favorite algorithms. We've taken a look at a bunch of different things algorithms can do, ranging from sorting, accumulating, searching, printing, everything like that. And you'll notice that algorithms take in iterators and functors. So yeah, once again, to reiterate, you guys can explain every part of this map now about the STL. And one last thing is that there is still more to the STL. Actually, not much more. You guys have learned pretty much all of the important concepts from it. There are some libraries that may still be interesting to you. So for example, the regex library, or regular expressions library. If you're looking into like parsing strings and you've heard of regexes before, like that's an interesting library. Another interesting one is about multi-threading. So how do you make your code work when you have multiple different processors that are running at the same time? The STL actually has a whole collection of things that work with that. So there's locks, condition variables, things like that. In fact, that is actually the lecture that we're removing from the sequence. You'll remember that we took an extra lecture in the STL, but we'll offer it as an option if you guys want to learn about it for our very last lecture. Yeah, so take a look at that if you're interested. And then finally, especially for those of you that are taking this class because there's a particular application that you want to apply C++ to, there's another set of libraries called the Boost libraries that aren't part of the C++ standard library, but they do provide a lot of really useful, not necessarily so common that they want to make it part of the STL, but useful enough that people use it everywhere. So this includes things like linear algebra libraries for machine learning, things like that. So the Boost is where you want to take a look if you want to take a look at sort of the next level above the STL. It's written by a separate organization than the STL, but they're also extremely widely used. Yeah, so Boost, that is what they are called. Cool. Okay, so one last concept to just wrap up the STL. So you've learned a lot of you've learned algorithms, functors, containers, iterators. One general concept to take away from the STL is this idea of abstraction. So really, in the STL, what we're trying to do is express general problems rather than specific ones. So to give you guys a sort of taste of this, we start off in computer science with things like basic types, like your characters, you have ints, doubles, strings, things like that. And so at the very bottom, we have basic types. But the question that we asked ourselves when sort of designing the STL was, can we keep track of a collection of basic types no matter what the type is? So abstracting away from the type, absolutely. And you guys already saw this. This is the containers in the STL. So we can represent a vector of ints or a vector of strings, no matter, and really a vector of any type, no matter what that type is. And so we've built an abstraction on types called containers. The next question, can we perform operations on containers regardless of what the container is? Does someone have an idea of where I'm leading with that? What allows us to perform operations without, no matter the container? Yeah, algorithms is a good answer. And what do algorithms work with? Iterators, there we go. So iterators are really, just like, well, this is an imperfect analogy, but just like mitochondria are the powerhouse of the cell, iterators are the powerhouse of the STL. So yeah, they allow us to abstract away from containers. And then finally, can we operate on iterators regardless of the type of iterator that it is? And it's exactly as we already said, we have algorithms that allow us to operate on any type of container using any type of function that allows us to not only calculate, say, what are all of the elements that are less than 5, but what are all the elements blank, blank, blank. So based on any predicate that we pass in. So yeah, this is just to reinforce that in the STL, really the two components that we take away as programmers are first, the amount of abstraction that it gives us. I didn't even mention templates, but templates, of course, are the most well-known of abstractions here. And then the other thing is speed. We've emphasized that the STL has been optimized for speed, and so yeah, so abstraction and speed. And so congratulations to you guys. That pretty much finishes up our STL units. And just to recall, that was the quote that we started with. We are lifting these abstract concepts like data structures and algorithms into their most general forms. So congratulations, you guys. Cool. So with that, something that I want to do before we jump into our big bring it all together example is a couple of announcements. The first one is office hours. So once again, congrats to everyone for turning in assignment 1. So we've updated our office hours. Since I can't stay after class on Tuesdays anymore, I've added an additional office hours on Wednesday. And then you can find all this information online on the Piazza. So yeah, so even if you don't have a picture now, you can find it on Piazza. On Piazza is also where we'll be updating like locations of where they are. So yeah, keep your eye on the Piazza.
I also want to just briefly mention something, which is these might change throughout the week, so make sure you check Piazza before you go to any office hours.
Yeah.
Okay. Yeah. Because especially like as different assignment deadlines are coming up, we might change these just to accommodate the assignment deadlines better. So make sure you check on Piazza before planning on going to office hours.
Yes, that's a great point. Yeah, and of course, also this class is almost personal enough that like if you guys can't make any of these, please reach out. And thank you to everyone who has reached out before. Yeah, we are glad to accommodate. Cool. Any questions before I go on to this? How do you guys? Okay, actually, I'm kind of curious. Now that you guys have finished the STL unit, how do you guys feel about the STL? Like, are you in love with it? Do you feel like, man, why did I just spend 6 lectures on the STL? Yeah, like thumbs, no. All right, yeah. Okay, cool. Awesome. So if there are no more, yeah, Brian.
Okay, I guess a question we should have asked at the beginning. STL is using namespace STD.
Yes, yeah, absolutely, exactly.
And STD is for standard template library, like.
Yeah.
Okay.
Yeah.
Not STL, not using namespace.
Not STL. That's actually an interesting point. Why isn't STD instead of STL?
Also do that.
Yeah, but yeah, no, that is a good miscellaneous question. Yeah, so whenever you guys have been saying like using namespace STD, now you know. Yeah, good question. Any other yeah, final questions? Cool. Well, okay, so since you guys are here, you also are going to get a sneak peek into assignment 2. So no worries about assignment 2. The way that we structured it is in 2 parts. The first one, and it's intended to break up a single assignment into just 2 easier to, I guess, like work with parts. So it's not twice the work. It is the same amount of work, just divided up. So the first one we are going to be releasing, I believe, tomorrow, and it will be due the Friday after. It's supposed to be not too hard. It's supposed to mainly be us checking whether you have working internet, because this one will actually require you to have working internet access. And then there will be, you'll have to work with algorithms a little bit. But to give you a preview of what assignment 2 is, so one of our goals in this class is to make it, to not only have you guys practice with the standard C++ libraries, but also to let you guys build some really cool applications, even with just, like 4 weeks of C++ so far. So for this assignment, what we're going to do is, how many of you guys have heard of something called wiki racing? Yeah? Okay, yeah, can one of you explain what it is? Yes.
So it's when you try and reach one site from a random site on Wikipedia with the fewest amount of names.
Exactly, yeah, so, yeah, no, that's exactly it. So if you didn't hear that, it's wiki racing is you trying to reach, you're given 2 sites, and you're trying to reach the second site from the first site using only Wikipedia links. So you start on one Wikipedia page and have to click around till you reach the next one. And the winner is the one that does it in the fewest clicks. Does anyone know what page supposedly is reachable by every other page on Wikipedia? It may not be completely true. No?
Philosophy.
Yes. Say it louder.
Philosophy.
So it turns out the page philosophy on Wikipedia is reachable by pretty much any other page. But yeah, feel free to try that out on your own time.
And I think it's if you just only click on the very first link. So if you go on any Wikipedia page and you click the very first link, like here you click place. If you just keep clicking the very first one, apparently for most pages you'll end up in philosophy.
Yes.
Yeah.
So feel free to try this on your own time. We this is tempting, but we won't do it for the entire lecture. Yeah, okay, so that is what you guys are going to be doing. You're going to be building an automated way to find race completions between two links. So it's going to be very cool, and you'll realize that you can do it with very few lines of code using what you know now. So we'll release the spec tomorrow, and you can take a look at that. One thing I wanted to make sure to just recap quickly from the spec is it'll mention something about returning an unordered set as opposed to a set. Does anyone remember what this is? And I wanted to cover it because we went over it basically in like 30 seconds. Yeah.
It's like a map versus an unordered map would be a map versus a hash map.
Exactly, yeah, exactly. So if you guys have taken a look at hash maps or hash sets in 106B or X, unordered maps and sets are the C++ STL equivalent of that. So rather than guaranteeing that it'll output all of your keys in sorted order, it guarantees that instead you can access them really quickly. So yeah, the spec will mention that for one of the functions that you're writing, you'll want to return an unordered set. And the reason for that is because in this case, we are only accessing individual links on a page in this example, so it doesn't actually matter whether those links are sorted. Yeah, so that's a bit of trivia in case you're interested, but yeah, don't get confused if you see unordered set instead of set. Cool. Any questions about that? Yeah.
So is that a tree set?
Is that a tree set? Yeah, that's a great question. So a tree set is slightly different. A tree set, I believe, it has to do with a different implementation of a regular set that also makes different promises. But yes, it is different. A tree set is actually closer to a regular set than an unordered set. Yeah, good question though. And one other thing, for those of you that don't keep up on the Piazza as much, we actually posted a link to the Stanford C++ libraries on Piazza. So if you want to go in and see, say, how a tree set is implemented, you can go in and read how they've implemented a tree set using standard C++ functions, and data structures. Yeah. Awesome. Yeah, any other questions? Cool. All right. So in that case, what we're going to do with the rest of lecture today is take a look at an interesting example problem and then see how we can solve it using everything that we've learned. So let me introduce you guys to the problems first, and then this one will be sort of a more interactive lecture than previous lectures, also which is nice because we're somewhat smaller today. So yeah, it'll feel almost more like your 106B or X sections if you're in that. Okay, how many of you guys have heard of the Federalist Papers? Yeah, okay, awesome. So the Federalist Papers, if you're not familiar, were a set of essays published back when the Founding Fathers, or back when America was trying to ratify its Constitution for the first time. So when it was trying to establish itself as a country, they had to argue, essentially they had to argue over whether the Constitution should be ratified or not. And so the essays were published by 3 different authors. Here we go. Hamilton, Madison, and John Jay arguing in favor of the Constitution. And so they've gone down as a really important piece of history because, in a sense, they also outline a lot of the philosophical rootings of America. But one interesting debate that's gone on about the papers is which of the papers were written by who. So the Federalist Papers, there were 85 of them written, but the authors never really explicitly came out and said which author wrote which paper. And so it's been a sort of interesting puzzle for everyone down the line to say which person actually wrote which paper. And so what we're doing today is writing something that will let us know which author most likely wrote which paper. So our question that we're going to be solving is, can we discover an author's identity from their writing? And this is sort of interesting. It's actually an entire field called stylometry, which is this right here. So based on this description, can anyone give a guess for, just on a very high level, how are we going to be able, given a piece of writing, how are we likely going to try and detect which of the 3 people wrote that piece of writing? Any ideas? Yeah.
Like, if we have samples that we know are from certain people, we can compare, like, word frequency, like which writers tend to use which words more often.
Yeah. So that's a great guess. So it's sort of like when people are trying to sit down themselves and ask like, okay, how can I determine which person wrote which paper? Yeah, one idea that they might think of is, oh, okay, I can compare the word frequencies between the writings that I know they wrote versus the writings that I'm unsure of. And actually, that's exactly what we're going to be doing today. So that's perfect. Yeah, Brian, what's up?
ML.
Machine learning. That's the new electricity. And class is over. Thank you, guys. No, I'm just kidding. Yeah, that would be an interesting extension, though. But yeah, machine learning, people use that for that, of course. Awesome. Yeah, so going back, so the idea is that authors have their own writing style and tend to write consistently. And so our goal for today is first to be able to identify some way of like fingerprinting them and then coding that all up. So the invariant that we're going to use so I guess the question is, what words do we want to count the frequency of? Because, for example, some words may not actually be relevant to which author wrote which paper. So common words like these give a sort of unconscious fingerprint of the writer's writing style. So as a general idea of what we're doing, let's imagine that there are 3 function words that we're working with, I, the, and there. And so the way that our code is going to be able to identify which author it is something like this. Sort of intuitively going on and seeing how many of each there are. In this case, there are no the or there's in the text, and then the same with these.
Wait, no, there's one there.
There is a there. Thank you. Wow. All right. This is gonna mess our. Nah. Good catch. We will go back and fix it. Nice. Perfect. Okay, so now that we've built up the word frequency counts, I guess now the next question for us is, how are we going to use these to tell whether the authors are similar or not? And the idea here is something that we're actually going to be taking from math. So how many of you guys have heard of a dot product? Nice. Perfect. So we are doing cross-field learning, and we are going to be taking the dot product of our 2 word frequency vectors to let us know basically how similar are the 2 word frequencies to each other. So our favorite equation. And if you don't understand this, don't worry. The code, if you're interested, you can come talk to us afterwards, but the code will just rely on us knowing the equation and not necessarily why. Awesome. So before we get coding, do you guys have any questions about the problem setup? Or any historical questions I may or may not be able to answer? No. Cool. Okay. So, right, our wiki race. Okay, so one of the other goals for the class that we've been hearing a lot about and that we wanted to give you guys was sort of how to start writing a program from scratch, essentially. So we are going to start writing from Hello World. So part of the point of today is not only to work with the STL, but also just how do you decompose a program? How do you write a program? Yeah, we'll be working on all of that together. So once again, starting from Hello World, the first thing that I want to mention is that you'll notice that in basically all of your programs in BRX, you just put using namespace std semicolon, and then you don't have to worry at all about using something like std cout ::cout afterwards. We actually want to de-emphasize that use, partially because you can imagine this as sort of like throwing the entire fire hose at your program. So we've just seen how large the STL is, and what this is saying is it's saying bring all of it in. So what we would want to use instead is actually be pretty granular and be like, okay, I know I want to use cout, but it is pretty annoying to have to do something like std : cout every time I want to use it. So what we can do instead is something that I believe Avery mentioned really briefly in one of the previous lectures called an alias, in which, in this case, it's a using declaration where we're saying, anytime I say cout, I really mean the std cout, and same with the endl. So this is common style, and this, so in a single file program like this one, then using namespace std doesn't really matter. But where this can get you in some trouble is when you start writing big classes and different classes that are working together in a single program, which is actually what we're covering next in object-oriented programming. So in that case, then using this can get you into some trouble because say you have some functions in here that you redefine in another namespace elsewhere, and it starts getting confusing which one you mean. So it's a good exercise to just get used to using very particular declarations right here. Yeah, question?
What's the difference between using include and using?
Can you say that one more time?
Sorry, what's the difference between what using is doing and what include is doing?
Yeah, that's a great question. So what's the difference between these two lines, include and using? So what include is doing is it's bringing in a library of functions. So it's bringing in like a code that other people have written, or I could say it's bringing in the class itself. What using is doing is it's telling the program which function from those classes do you want to use. So in this case, it may seem kind of confusing because there really is only one cout that we're working with. But say that there was another library called like my bad library or something that also defined a cout function, then this program would have no idea which cout you meant. And so you would have to specify. Yeah, and so syntactically, this is saying, okay, even though there is no duplicate, I still have to specify which cout it is that I'm using. Yeah, great question, great question. Awesome. Okay, so I lied a little bit that we are going to be starting from scratch. So this is the main function, and we can confirm that it runs by, let us try running. Hello world, perfect. But for the sake of time, I actually have given us a little bit of a head start. Oops, not that one. So I've actually already written the main function for us, which all this is doing is just giving us the blueprint of what we are trying to do. So let me go through this bit by bit. So in terms of what it is that we want to do to solve this problem, the first thing that we're going to need to do is read in the files that we're working with. So our approach is, let's take in one file by Madison, one file by John Jay, and one file by Hamilton. And then our goal is to figure out which person wrote this unknown text, who we're not sure who wrote it. And so the first thing we're going to need to do is process the file so that we can actually read it in and figure out the word counts. And then finally, what we're going to do is we're going to output the similarity between each of the authors and the unknown one so that we know what's the likelihood that each of them wrote that text. So you can sort of see how it is that we know, for example, one question that people have is like, how do you know what things to include at the top? You can see, okay, I know I'm going to have to use an IF stream, therefore let me include an F stream right here. And then don't forget that once I include it, sorry, I'm unused to Mac keyboard shortcuts. Here we go, there we go. So using std IF stream, and then perfect, now it's stopped complaining. That's right, and then string. So I'm going to need to include string, and then of course, using std string. Awesome. And then we can see, of course, file to string and get similarity are complaining because we haven't written them yet. One last thing that I'm going to import from us that we aren't going to write together is actually the list of the function words that we're going to be comparing on. I could have typed this, but we won't. And then you'll notice from here, that's right, I also don't have a vector. So here we go, time to include vector. And as always, using std vector. Perfect, and now we see that it recognizes everything. And what I'm doing right here, if you guys haven't seen this before, is I'm declaring this a constant. And again, we can talk a bit more about declaring global variables like this constant versus not. But again, because we are writing a single file program, it doesn't matter as much in this case. But yes, any questions so far on this? I'm going to hide that. Awesome. Okay. So in that case, what we're going to do, let's try implementing this. So the very first function that we want to write, so I guess one question might be is, why do we need to process the file at all? Why can't we just start using it immediately? Can you guys think of a reason why? So actually, let me show you the file. So let's say our file is something like this. And remember, let's say our function words are things like it or is or the. Take 30 seconds and talk with your neighbor. Why can we not just immediately go through this file and count word frequencies? What is one problem that might arise? Feel free to brainstorm. So, yeah.
Yeah, anything.
All right. Okay, does anyone want to volunteer their answer? What is one potential thing that you might be worried about if you were trying to count the number of function words in this file? Yeah, in the back.
Like punctuation.
Yeah.
Together with words, so like you can't really just count like spaces, otherwise you would include like periods, and that would make things different even though the word is the same.
Yeah, no, that's a great point. So what happens if a word like removed is one of our function words and it's followed by a period? It seems like that's a little hard to work with. Sneak peek is that our program actually still won't handle that case, but it's a great extension if you guys want to go after this lecture and modify our code to handle the punctuation as well. But that is 100% a valid concern. Yeah, so that's a great one. Are there any other ones that people thought of that are reading in this file might cause trouble? Yeah. Yeah, exactly. Yeah, no, great point. So in this case, take a word like is. Remember that even though to us this is and a lowercase is are the same thing, when you're reading it from a file stream, capitalization and lowercase are not the same thing. And so absolutely, capitalization is something that we have to worry about. So that's actually the one problem that we are going to solve right now. And again, I encourage you guys to go back and solve the punctuation problem as well. But so let's take a look at our main.cpp. Okay, so that is why we need to process the text at all and why we can't just use the file stream directly. And again, there are other ways that we could have designed this, but this is one way that we can do it. So let's see. So I know that I want to create some function that converts a file stream to just a string of all of the words that are lowercase or uppercase. So what we're going to do is string file to string, if stream, and then we're going to pass that by reference. Let's see, file. And actually, one interesting relation is that if you don't pass it by reference and try to build, it won't complain yet. Yes, right here. So you'll notice it says error call to implicitly deleted copy constructor. That's just a sneak peek to what Avery will be talking about with copy constructors. But basically, that's preventing you from passing it by value. So we will have to pass it by reference. Awesome. Okay. So once again, our goal is to read in the lines of the file from the file and create one single string that has all of the words separated by a space out. So for example, instead of having something like this, what we want to do is have something like lowercase it, lowercase is, et cetera, with no new lines. So I'll start this function off for you guys. So string. So we want to somehow return some string. And then at some point, we know that we are going to have to be using getLine. And on getLine, the way that we use it, again, as you guys know by now, is we pass in the string as the first parameter, and the string that we want to read into as the second parameter. Okay, so knowing that we're going to be using getLine, why don't you guys take another minute or so and talk to your partner, and just discuss with each other what is the general structure of this program going to look like. Like, am I going to be using loops here? Am I going to be using, how do I want to change each word to its lowercase version? Take a chance to discuss with each other. Feel free to look at the CPP algorithms page to see if there are any interesting algorithms that could help with this. But yeah, take this time to explore. You don't have to have come up with an answer by now, but just to get the brain juices flowing. Yeah, go for it.
It's about 20 minutes.
So you have to actually get line in a loop, right? Yeah. I think I forget the syntax. And then while you do that, there's something called like two lowercase. You do two lowercase in line, and then you just shove that into
Strings.
I think.
Awesome. Okay, let's come back together. What ideas do you guys have? Feel free to raise your hand or shout it out. What ideas do you have about how to write it? Any component. I heard some good ideas out there, so I know they're there. Yeah.
Just do a while loop.
Perfect. So we know that, oh my gosh, I'm sorry about that, you guys. So perfect, a while loop around our get line, and then what sort of things do we want on the inside? Not necessarily the syntax, but just what is our goal? What are we going to do on the inside? Yeah.
Check every character, and if it's uppercase, we lowercase.
Perfect. So one idea is check every character. If it's uppercase, make it lowercase, and or vice versa. We can make everything uppercase. The common theme of this, of course, is do you think the STL has something like that that will do this for us? And or do you remember anything from the algorithms lecture that might do this sort of functionality? Go through every character and make it lowercase if it isn't already. I see a hand there. Okay. Yeah.
Isn't there a too lower function?
Yeah, absolutely. So there is a function called toLower that looks like this, and it's actually from the CC type library. So the way that we might have done this before you taken this class is doing something like for like car C in line, like toLower, like C equals toLower of C or something like that. And then at the end of that, we do something like ret plus equals C. There's actually, so now that we have our function, so now that we know that there's a function that does this for us, what does that make you think about? So what does the STL have that can take in functions and apply them to every character in a line, for example? Does anyone remember a potentially useful algorithm there? Yeah, right. Yeah, so lambda totally works. And in fact, in this case, actually, the function that we want to do, so a lambda is the function that we want to apply. So what is the function that we want to apply in this case? Yeah, okay, so putting these two answers together, and actually all three answers together. So I heard the keyword transform, I heard the keyword the toLower, and the keyword lambda. So as it turns out, exactly. So transform is an algorithm in the STL, transform, and you'll notice it's not recognizing transform as a valid thing, and that's because we have not included algorithm. So we are slowly building up our library use. And then now if we type in transform, you'll notice that Qt does a really, right, sorry, and we also have to use, oh no, that should be fine. Yeah, okay. You'll notice that Qt also does this nice thing where it tells you what the parameters of the functions are. So I know, oh, okay, transfer takes in the first and last iterators of the thing that you want to transform. The third parameter is where you want to write that transform to. And then the last one is the function that you want to use. So in this case, what is the first iterator of the thing that we want to transform? Feel free to shout it out. Yeah, in the back. Nice, very nice. So exactly. So the thing that we want to transform is line itself. So the beginning iterator of that is line.begin. What's our second argument? Line.end. You got it. And then where do we want to write to? In this case, we actually have choices. It turns out we can just write to line.begin again because we are taking in one character at a time and then replacing it with its valid character. So you'll notice that strings are mutable in C++, by the way, if you didn't notice that. Yeah, go for that.
Should we write line.begin over begin line?
Great question. So the question was, we saw last time that there was both begin line and line.begin. It turns out if you look at the implementation of begin line, it really is a call to line.begin. So you can choose either one. There are very minor differences, but in most cases you won't run into those differences. Yeah, one just deals with one edge case that the other one doesn't. Yeah, so line up begin and begin line are equivalent. Awesome. And then in this case, what is the function that we want to apply to every character in the line? To lower with confidence. To lower, exactly. Awesome. And so that actually did exactly that. So our favorite thing with the STL, getting rid of for loops. And then finally, what we want to add to the thing that we're returning is line plus one extra space. And that's because getLine is returning the line to us with the new line stripped. So if we want to return everything as one string, we're just going to use the space to separate all the words. And then, of course, the very last thing we have to do, return print. Any questions about this? Yes. Go for it.
So if you want to pass in the toLower function, you need to include the CC type.
Yeah, great question. So why is it that we can just pass in, why do we not need to include CC type? So we actually totally could. We could write include up there, up here. And it would perfectly compile. It turns out CC type is already included by another one of these libraries, so it already knows it exists. But yeah, we can leave that in there just for clarity. Yeah, go for it.
What will the toLower function do for punctuations?
Yeah, great question. What does toLower do for punctuation? Returns it unchanged. Yeah, that's a great question. Yeah, any other questions? Yes.
You could have also just like put it straight into red, right?
Ah, that's an interesting question. So the question was, in this third parameter where we're specifying where to write the transform to, couldn't we have just put that directly into this ret variable? And yes, we could absolutely try that. We could do something like std transform, line.begin, line.end. And then using the iterator adapters that we learned, we could do something like back inserter a character to, let's see, what's the syntax? Back inserter, it was to ret, and then the thing that separates it. Yeah, so, and in this case, since it's characters, we don't want anything to separate it. And then finally, toLower. That actually works perfectly as well. Right. So if we wanted to use back inserter, then there is actually another class that we would have to use called inserter.
Does it take two? Does it take that extra space?
I'm pretty sure it did, but maybe not. Okay, no, it doesn't. I'm thinking of the outstream operator.
Try removing the char, the bracket char.
Yes, that was it. Thank you. Yeah. Alternatively, right, okay, so alternatively to back inserter, we could have done, yeah, so I guess not OStream iterator, because I would write to see that, yeah. So that's perfectly valid. It's actually interesting, if you try this, you can actually guess which one of these will run slower. I won't do that now because there are other things that we want to do, but it turns out that this method is actually slower than this first method, because in this case, you are having to insert one character at a time to return, whereas here, you're already working with lines, so you don't have to expand return on every insert of a character. So yeah, small differences, but yes, this is perfectly valid. So I'll comment that out. Awesome, yeah, any other questions before we move on? Cool. Yes, okay, so this is telling us what we want to do next. So now we've properly processed our files to be ready to count word occurrences in them. So now let's try computing the similarity between, so now we are on to the bulk of our actual algorithm, which is get similarity. So the first thing we're going to do, I am going to write. The thing that we want to output is some decimal value that represents the dot product of two feature vectors. You'll remember is our final goal. So we're going to output a double get similarity between a string 1 and a string 2. Okay, So I'm also going to write this pseudocode for us as well, because this gets back down to the algorithm of how we would compute the similarity. So you'll remember from the slides, what's the first thing that we need to do on each of these vectors? What is the first thing that we'll need to do? On each of these file strings. Yeah, go for it. Yeah, compute the frequency. So let's do that first. So we'll want to compute a vector of ints, so the frequencies of, let's say, freaks vec1, and then let's do the same. Oops. On 2. And then what's the next step? Do you guys remember from the slides? If not, I can also share it. Once we have the two feature vectors, what is the next thing that we want to do between them? Yeah, say it louder. Dot product. All right. So once again, we don't have any of these functions, but we're just writing out sort of our pseudocode in terms of what we do want to implement later. So this is one style of coding an assignment where you first this is like a top-down approach. You first figure out what are all of the general things that you want to do, and then you go back and implement the functions later. Exactly. So we'll compute the dot product of those. And then the final thing, if you didn't remember, is that we are going to have to do something. If you look at the equation again, the cosine theta is the thing that we want to return. So we've taken the dot product, which is the numerator, and then our denominator is we'll want to divide by some sort of the magnitude of the first vector times the magnitude of the second vector. And that'll need to be in parentheses. Perfect. Any questions on that? If not, we can also dive in. So create frequency vector is going to be the biggest part of this program, and actually that is going to be the part that'll be applicable to your assignment 2. You can basically just lift the code directly from this class example, so keep an eye on that. So let's actually implement that first, and then if we have time, we can do mag and dot product later. If we don't have time, I'll leave it as a challenge to do the magnitude and the dot product, because they're actually each one line each using a single STL algorithm, which is kind of cool. But let us do this one just so that you guys can see what you're going to be using for your homework. So create frequency vectors. We're going to be doing a vector of ints, create vector const string, and let's say text. You'll notice it's still complaining that it doesn't exist. Reason for that, you might have seen in your assignments, is because we've declared it beneath when we first use it. And so one way to get rid of that is either to move our entire function up above where we first call it, or to use function prototypes, which I believe you've seen in your assignments. So once again, what that is doing is that's just declaring the function before you implement it, so that the compiler knows that that function exists. So that's a minor thing. If you're interested, we can talk later. All right, so I'm going to write this one for you because this one won't hold the bulk of the algorithm. So again, our goal is to create a vector of how frequently each word in this vector appears in the file. There are a couple different ways to do this, and this might not seem like the quickest way to do it, but again, this will actually be the way, this will be more useful for you for your assignment, so we're just going to do it this way. And it turns out it's not much slower than other ways of doing it. Let's do, basically what we're going to do is for each word in the frequency vector, we're going to look through the entire document and see how many times that word appears. So for each word in our frequency, in our feature vector, we're going to do result, push back, and then let's do some sort of our favorite count occurrences, which has appeared so often in our examples, of the word in our text. And then finally, return result. Cool. So once again, we're just building up and in a sense, sort of pushing back our algorithmic work each time. Cool. And then so the last thing we want to do, so once again, this is saying for each word in the frequency vector, count how many times it appears and then add that to the vector. So now we are going to be doing the biggest portion. So this is going to be const string and word const. Awesome. So one thing I want to do, so I'll set you guys up and then I want you to take 1 more minute to talk to each other. Let's actually take 2 more minutes and then we can maybe finish this at next lecture. Take 2 more minutes to discuss how you might go about counting the number of times a string appears in this text. And before you do that, I'll give you one setup. So we mentioned earlier that punctuation was an issue. There's actually one other issue, and let's see if you guys can recognize it. So let's say that one of our words is like the. What's one issue with trying to look through a single string for how many times the word the appears? It's a little tricky. Oh, yeah, you might be thinking of it. There, the and there. How many times will the be recognized? Twice as much as it should be, because it also appears in there. So to deal with that, to deal with the fact that the is a subset, or is a word that appears within other words, we're actually just going to do a sort of small hack and say, the word that we actually want to find is only the full word itself. So only, and notice that this is what I meant by we aren't dealing with punctuation, because what if it ends in a period? So that's actually a really big component that I would encourage you to go implement after this lecture. Cool. So I want you guys to take the last minutes of class to talk with your partner about how you might implement this count occurrences. And I'll give you a hint. One thing that you guys might initially be thinking of is the STD algorithm count, because it seems like, oh, we want to count occurrences. I remember there's this algorithm called count. Read up on how count is implemented, and I'll tell you that it's not count. It's another algorithm in the STL that you're looking for that will help you here. So your homework for next lecture is to come back with what that algorithm is, and then we'll take the first 5 minutes of next lecture to finish this up. But right now, take the last minute to talk with a partner next to you, see if you guys brainstorm any ideas, and then we will be dismissed. Awesome.
Wait, what's wrong? Just like, remember in the first lecture, we just ended to a string, like when we did CN earlier, to a string and it took in the first thing. Can't we just go through that?
And just do CN through everything?
Yeah.
Exactly, so have a while loop over the CN and read in the file word by word.
Right.
So that would totally work. One issue with that is that you can only read through any IF stream. Well, actually, no, that's not true. I guess you can rewind.
It have to be just exactly one word.
So there's that, so which is a good point. In this case, so I would say that you could actually implement that as a valid solution to this. And what the STL is doing is it's providing a much faster way of doing that. So that is sort of like, that is the naive solution. Yes, yes. There is a better one out there. Awesome. Cool.
We can start get set up.
Yep. Awesome. So yeah, feel free to continue talking to each other over the weekend. And I will see you guys on